Hey everybody, I'm going to make up a little video here to help you with the post-lab calculations and analysis of lab number 11. As part of the calculations section of this lab, you need to create a plot and plot a line of best fit of your absorbance data. Number 2 in the lab write-up in the calculations section says plot the absorbance of the 5 copper solutions from part 1 as a function of concentration. So when you do this, you're going to plot each data point in an Excel spreadsheet or Google Sheets or something like that and generate a graph or a curve, a scatter plot. So you're going to graph the absorbance versus molarity. And you've probably figured out by now that the higher the concentration, the higher the absorbance. So in your most concentrated solution, your absorbance was very high. And then in your next, it got progressively lower. And so you maybe have data points that lie on a roughly straight line. Now it's worth mentioning at this point that some students like to generate this curve on the lab quest itself, but it doesn't come out as neat and clean. And you're trying to save yourself a couple steps, but I'm going to ask you that you do this in a spreadsheet and generate a curve using Excel or some sort of similar graphing application. Because these applications can actually generate a line of best fit for you rather than using an old straight edge with a pencil sort of scenario. So with the application that you're using, you need to generate a line of best fit. And in this case, I'm going to sketch one in, and I'm just going to say that's the line of best fit. If possible, and it is possible, you just need to dig around for it, you can actually come up with the formula for the line in the form of y equals mx plus b, where m is the slope and b is the y-intercept. Now you might be asking yourself, how does this formula for a line help me in figuring out what's going on in this lab? Well, I'm about to tell you. And it says in the calculations, the first paragraph talks about Beer's law. Beer's law states that the amount of light absorbance in a solution is directly proportional to the ability to absorb of the coefficient of the glass and the water. It's also based on the width of the light path and also the concentration of the sample. The law is often written as A, capital A, equals A times B times C plus 0. Now oftentimes they leave off the plus 0, so it's just A equals ABC, but I'm going to put the plus 0 in because we're going to make that our y-intercept. So A is defined as the absorbance. And A and B, lowercase a and b, you can treat A as a coefficient of the glass and water. It's a constant number. It's a number you really don't need to worry about too much. And B is the width of the light path. Now in each one of your calculations, A and B were constant. Those two values just multiply together and in fact become the slope of the line. Now as for C, C is the concentration, and that's the other variable in this formula. We call that, well, X. So basically, absorbance is equal to M, which is the slope, times X, which is the concentration, plus 0, which is the y-intercept. And as you probably would suspect, at 0 concentration, you should have 0 absorbance, so the y-intercept should be 0. So how does this apply to your graph? Well, when you generate the line y equals mx plus b, you're really generating the A equals ABC plus 0. And so for your unknown, you plug in the absorbance for the unknown, and you can then calculate the concentration of the unknown. Because Beer's law says that the slope of the line is equal to A times B, which is constant, and that then A and C are proportional. And to be honest, Beer's law is one of the most consistent relationships that I've ever observed in AP chemistry. These graphs pretty much hold true, and you get pretty low percent errors as long as you did the lab correctly. You will have a pretty low percent error. Your unknown concentration will be very close to my known unknown concentration. So make sure you click on the link at the end of the lab to see the unknown concentration. There's a little link down there. So anyway, that takes care of this video lesson. Thanks for listening.